Hello and welcome to Unit 8. So far, we have different modules. We have learned what econometrics is. We have learned the basics of estimating an econometric model. We have learned the basics of hypothesis testing. Then we look a little bit into model creation. How do we actually choose the independent variables we want to use? How do we choose the right specification for them? In this last module of the class, we're going to be looking at what can go wrong. The first problem, or the first thing that can go wrong, is a problem called multicollinearity. And this has to do with some of our independent variables to be highly correlated. That makes it very difficult for a regression to be able to disentangle the effect of one variable over the other on y. Pretty much in these next 3 chapters, we're going to be doing the same thing. First, we're going to be defining the problem. In particular for multicollinearity, we're going to be looking at the difference between perfect and imperfect multicollinearity. Then, of course, we're going to be looking at the consequences of multicollinearity in our model. Then we're going to be looking at the detection of multicollinearity. In this class, we're going to be very limited in terms of the depth of tests that we can use for detection of multicollinearity. We're going to rely mainly on high simple correlations between our variables. We're going to be looking at whether our coefficients become erratic when we include a variable or when we drop it. And we're going to be also looking at the high variance inflation factors as our basic tests for figuring out whether multicollinearity will be a problem in our dataset or not. Lastly, we're going to be looking at remedies for multicollinearity. If we're looking into perfect multicollinearity, the remedy simply becomes to drop one of the redundant variables. But if it is imperfect multicollinearity, our choices are limited. We can either combine the variables, that is, we're going to have to lose some of the personality of each of the variables into our model, or we can simply try to increase the sample size to remedy the problem of high correlations.